Good morning, students. Let us start the class of information theory and coding. We are coming to the last part of the first module. Just recall whatever we have learned till now. In the beginning, we learned about what is information and what is knowledge, and later on, the relationship between the information and the probability. Later on, the properties of self information, that always this information is logarithmic in nature. And then later on, we defined something called entropy. Entropy is the average information content per symbol, where symbol is nothing but a representation of some other character or some other data that is going to be produced from the information source. And we always discuss discrete information sources because we primarily deal with digital communication. So recall all those concepts and also recall that information rate equals symbol rate into entropy. Capital R equals small r with the suffix s into the capital H. So this is evident that entropy is the average information content per symbol and RS is the symbol rate. So naturally you will get the information rate as bits per second. It is bits per symbol into symbols per second will lead to bits per second. So recall all those things. All these basics are very much essential for the understanding of this information theory, because based on these basic concepts only, the next modules are going to be dealt with. So now we come to the very last section in this particular module, that is called Markov statistical model. I thought, let me make these lectures more and more colorful or more and more decorative by using PowerPoint slides or by using animations. But I could not find immediately any such material which is available in the net as such. The reason is this is a very primitive fundamental course, and in general this course is studied primarily by electronics and communication students. And even as far as the textbooks are concerned, we have chosen the textbooks. One is Sham Shanmugam and one is Simon Hekin, where all these concepts are discussed in a very abstract manner. Means if you go through the textbook, you will not find these lengthy discussions which are there in the textbook, because they are primarily dealing with digital communication. They are going to discuss the information theory only with relevance to the digital communication, not as an information theory as a complete course for one semester. That is where I could not find a lot of resources. And I thought, let me make my own PowerPoint. But if I make my own PowerPoint, what all these points, again I'm going to put it in that PowerPoint only. That is not going to give any value addition as such. So that is when I thought, let me discuss the notes which I had prepared as it is, because this notes contains all the points that are required for understanding. So wherever required, I'll use the annotate tool in this WebEx so that it will be little bit colorful and it will be little bit beautiful. Otherwise, understanding is understanding and beauty is beauty. They are two different things. Presentation is different and teaching is different as such. When both are merged together, it can be more inspiring to the learners. Anyway, as this course requires lot of exercises in future. There is no point in beautifying this course also. So even in the local authors textbooks, you will not find lengthy discussion of the theoretical concepts. You will only find lot of varieties of exercises, because this is more of a mathematical approach for information theory. I had to tell you all these things because otherwise you may expect that I'll keep on showing you PPTs or animations or all those things. But for the basic understanding, this much is sufficient. That is my opinion. So assuming that you are with me in recalling all the previous basics, let me proceed further with this Markov statistical model. So even though till now the information sources are considered to be memoryless, in practice nearly all the sources emit symbols that are statistically dependent. I have been telling this particular point earlier also. All the sources emit symbols that are statistically dependent. Till now we have been discussing about the sources where, let us say, I am typing into the keyboard of my laptop. I presume that in whichever way I type all the keys, I can assume that the keys are statistically independent and I can keep on typing the text matter. But in reality, all these characters are dependent. There is an example here. In English language, after Q, it is most probably letter U. Quick, quiz, queen, quiet. You recall all these words. Whenever Q comes, most probably after Q, it is U which is coming. Out of all the 5 vowels, A, E, I, O, U, U is most probably occurring after Q. That is how when they designed English language, they chose these alphabets and they decided upon these words. So we cannot say that Q and U are statistically independent, because after Q, it is most probably U, which means the occurrence of Q is dependent on the occurrence of U later on. Similarly, letter E occurs more frequently than letter Q. This is another example where out of the 5 vowels A, E, I, O, U, if at all we compare, even though U occurs after Q, in the whole of the English language, E occurs more number of times than Q. Just look at this sentence itself. In English language, English E, language E, after E, letter E, E, then letter again E, 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 then more, one more E. Frequently there are 2 E's. Again in letter there are 2 E's. In the sentence itself, you can count the number of E's that are occurring. So the letter E occurs more frequently than letter Q. This way we can find out the probability of each and every alphabet statistically in English language. Nowadays, anyhow, we have automated tools available. Automated softwares are available. Through these softwares, we can simply give the input as a complete textbook to this particular software, which can count the number of alphabets in the complete particular text. And it can give us the number of counts for which E occurs, A occurs, Q occurs, U occurs. That way it goes on. So whatever we have been assuming till now, we cannot continue with the same approach now. That is the basic point here. we cannot keep saying that the symbols which are emitted by the information source are statistically independent. They become dependent. Now their dependency is going to be measured by means of a model called as Markov model. Let me continue with this definition. Hence, the statistical dependence reduces the amount of information when compared to the independent sequences. See, the statistical dependence reduces the amount of information when compared to the independent sequences. How? Because now statistical dependence again relates to probability, and when there are dependencies, probability is going to be multiplied. Always the probability occurs between 0 and 1, which means it is always a fractional number. Any probability is basically a fractional number. Till now we have been considering probability individually for any given symbol, and we have been using these probabilities only as a summation for measuring entropy. But now when the symbols become dependent on each other, the probability of occurrence of u after q has to be measured now. Earlier we were measuring the probability of q separately and u separately. Now we cannot deal with them separately in future. The probability of occurrence of u is after the q, and the q is always dependent on the u after its occurrence. So now we have a probability of q as a fractional number, probability of u as a fractional number. When we multiply them together, we will have a fractional number which is less than the other two probabilities. For example, 0.1 into 0.2 will be 0.02. Even though probability of, let us say, u is 0.1, probability of u is 0.2, let us say probability of q is 0.1. Now if you have to consider both q and u, it will become 0.1 into 0.2, that is 0.02. So when the probability, it is called as the joint probability. You will have to revise the statistics which you had studied in the 4th semester or in the 3rd semester. You already had probability and statistics in the curriculum for maths, maybe maths 3 or maths 4. Now you will have to recall all those concepts, because in this particular course we are going to use all those concepts which you had studied in probability and statistics. As I have been telling you earlier, nature is randomly planned and nature is planned randomly. There is randomness as well as planning in nature together. So that is where whenever we measure planning of the randomness, we have to take care of, or we have to make use of statistical outcomes. So in such a case, statistical dependence reduces the amount of information when compared to the independent sequences. I told you the reason. When in case of the dependent sequences, we multiply the probability. When we multiply the probability, as probability is a fractional number, the multiplication of two fractional numbers will result in another fractional number which is lesser. That is what is the meaning of this statement. So it reduces the amount of information when compared to the independent sequences. A statistical model for such source emitting symbols in dependent sequences is developed now. That is this Markov model. A system which emits symbols according to certain probabilities depending on the preceding symbols as well as on the particular symbol being emitted is called as a stochastic or random process. Now remember the term stochastic or the term random, especially in the communication theory or in the communication applications, we keep on using these terminologies because we will have to model noise now, and we always should have a signal to noise ratio which is much larger. Let us say we send a signal in a wire channel or in a wireless channel. Now the wireless channel is more prone to noise than the wired channel, because the wireless channel is the complete shared channel. The free space itself is completely shared channel. Just visualize around you how many radio signals may be possible. Just visualize around you cellular phone networks are possible. Cellular service providers are there. Idea, BSNL, Airtel, Reliance. These four are predominant now in the present field, and they are all pumping radio waves into the free space with the 3G spectrum, with the 4G spectrum. This is the regular cellular communication, and around you in the free space itself, you will have all these four networks. Along with that, let us say if you are using a laptop with a Wi-Fi connection, you have a Wi-Fi around you, 2.4 gigahertz. Let us say along with that, let us say there is a FM radio broadcasting happening, and in the FM radio in Bengaluru itself, you will have nearly more than 10 radio channels. All those 10 radio stations are around you. You can tune into any radio station. You can tune into any cellular service provider based on whichever SIM card you have purchased. You can log into Wi-Fi network. Along with that, you imagine, let us say you have a dish antenna on the rooftop and you have a cable TV connection along with the dish antenna. Now you visualize, for the dish antenna, a multiplexed radio channel is being beamed from a satellite, and that is also there. The satellites are using this free space for broadcasting. Along with that, you visualize GPS now, global positioning system, where there are at least 22 plus 3 or 4 satellites there, 21 plus 3 or some number there, 21, at least 21 satellites are there, which are globally positioned so that they are continuously transmitting the location information, and your cell phone is GPS enabled, and the GPS enabling is happening through the nearest tower or the base station. Now imagine all these things, visualize all these things. Along with that, in Bengaluru we have a lot of cantonment area. In the cantonment area, even the military people are using this free space for their own private communication, secret communication. Now visualize all these things. When you visualize all these things in the free space, is the space free? That is the question now. Is the space free? No. Is the space empty? No. Space is not free now at all. Space is put into work by means of these many radio waves. Someday when the offline class starts, I will show you a PowerPoint slide where I have made a tabular column of all the radio applications, right from 300 megahertz till let us say 300 gigahertz, which are all the applications which we are using for the radio communication. Maybe in the next class, in this session itself, maybe in the next class, I will add up those 2 slides just to give you an idea about how we are using the free space for wireless communication. And this free space is not free, it is busy, and the free space is not empty. In general, people say space is empty. Now the space is not empty, space is filled with radio waves. In that case, how would we model the communication now? Now in this free space, there is enough noise generated either by nature or by human beings. There are industrial noises which are again pumped into free space, and nature generates its own noises. Along with that, there are electromagnetic noises, which are again part of nature or part of the human communication. So, in such a case, how do we model a noise? Noise can be modeled as a random process or as a stochastic process. Now, which means what? I'll come back to this definition. A system which emits symbols according to certain probabilities depending on the preceding symbols as well as on the particular symbols being emitted is called as a stochastic or random process. Such process can be modeled using Markov processes, also called as Markov processes. The name is also there as Markov processes. Now, why do we use this specific term called stochastic or random? The reason is we cannot predict noise as such so easily. At times, we cannot predict the transmission also so easily. Now, what I am going to speak after about 5 minutes is right now not known to me. That means when I come to that particular topic, I am going to discuss what I am going to speak. For example, I have given an example of how free space is filled with radio waves. This example which I gave you, I did not think about giving an example 5 minutes before, which means it was not planned. When I started the class, I did not plan that I should give an example of how the space is filled with radio waves. It came out spontaneously. Now, can we say it is random? Yes, it was random because I did not plan it. But just because it is random, can we say that it is observed? No. Whatever example I gave you is not observed, which means it is information only. But the information which is not fully planned, that is why it is called as a stochastic process. So the term stochastic means that, or when we use this term as random, let us say we use this term stochastic or we use the term random, it does not mean that whatever we call as random is waste, or whatever we call as random is useless, or whatever we call as random is meaningless. No. Randomly also information can occur. And when information is occurring randomly, that randomness also will have a probability of occurrence. Because in my class now, I give all these examples. There is a probability of me giving such examples in future also. And they are also informative only. Even though they are not planned, even though they occur spontaneously, they are not waste, or they are not useless, or they are not observed. Such processes are called stochastic processes. This is a philosophical term which is used here as a technical term. So remember this, there are enough number of people who are doing research on stochastic processes, including maths people, including the mathematics professors or even the industrialists, lot of engineering enthusiasts or engineering faculty members or even the industrial employees. They conduct a lot of research on stochastic processes, because how do we communicate information in spite of noise? Noise cannot be completely eradicated at all. Now, in spite of the noise which is prevalent, how do we communicate? That itself is a great study. And we will have to measure the efficiency of our communication, which means we will have to take advantage of the stochastic processes only. For example, I will give you one more example. Let us say we have an offline class, and let us say it is a summer season. In the summer season, when offline class is going on, all the fans in the room will be moving. When all the fans in the room will be moving, all those fans are introducing noise into the space between you and me. Now, how do we communicate effectively in spite of that particular noise. That is the challenge. We cannot completely remove the noise from the communication. In spite of the noise, we must be able to communicate. And in such case, we have to make use of the stochastic nature or the random nature of the processes. What we do is we relate probability with the randomness. And through probability, we find out or we measure the efficiency of the channel. That is the essence of discussing this Markov processes. The term stochastic itself is a much larger word. Now, such a process can be modeled in many ways. One such model chosen here is Markov process or Markov process, because it is the name of the person Markov who modeled a stochastic or a random process in his own way using joint probabilities. There are many other models available, but this has been a popular model for communication systems. In fact, earlier we had one course called telecommunication and switching. Now, the same course is being offered in the autonomous stream as digital switching systems, which is actually a very good course. In that course, again we are going to use this Markov process to model the working of the telephone exchange, which means in the telephone exchange, how the calls are random. From morning till evening, let us say a telephone exchange is going to handle thousands of calls or lakhs of calls. When it is handling thousands of calls or lakhs of calls, all those calls are not planned in the morning. All these telephone calls are happening from morning till night, not with the serious planning, because we don't know when who will call whom. But all these calls are not useless calls or waste calls. So we can say the working of a telephone exchange itself is a stochastic process or a random process in that angle. Means none of the calls will be planned as such. Even in your case, in your cell phone, from morning till night, what all messages you receive or whichever messages you send may not be strictly planned for a particular time duration. It all occurs, such communication occurs only as the need of the moment. When the need of the moment arises, you will call somebody, or when the need of the moment arises, you will message somebody. Now, you cannot say it was well planned, so you can say it is a random process. At the same time, you cannot say that process is a absurd process or a useless process. Then it is called as a stochastic process. Okay. So this stochastic process, how do we model? It is actually not very easy to model the stochastic process because it has randomness. When it has a randomness, how do we model? Modeling itself is planning, right? Any modeling is basically planning. But when there is a randomness, how do we implement planning in randomness? That is where the difficulty is. But many people have tried out at least a nearby model which can fulfill. A model which can fulfill. So, one such person is Markov. Markov has used these models extensively, and later on the same model was used for modeling a telecommunication traffic. Now, the same model is used in information theory also. Why? Because information theory again is dealing with communication traffic or telecommunication traffic. That way, such process which can be modeled is called Markov process. In other words, stochastic process can be modeled using Markov process. Markov process uses only joint probabilities. It will be clear for you when I discuss the next exercises. So let us see in a little more detail. If you have any questions, you can always put it in the chat box, or else you keep listening. Now the characteristics of Markov process are: the source is in one of n possible states, and if it changes state once during each symbol interval, the probability of this transition is Pij, which depends only on the initial state I and the final state j, with no dependency on the other states. Just imagine I am leaving my home to reach college. When I leave home to reach college, from Vayalikaval 12th cross, I come to Vayalikaval 11th cross, then I come to Palace Guttalli Vinayaka circle, then I come to Guttalli underpass, then I take a right turn there or a U-turn there, then I come all the way through that Windsor Manor bridge and I come that way. Now imagine this way, that I am starting from home. When I am starting from home, initially I am at home, then I should come to 11th cross. So imagine, first state is my home, second state is 11th cross. From 11th cross I come to Guttalli circle, so that is the next third state. Then I come to Guttalli underpass, that is the fourth state. Then I come to Windsor Manor bridge, that is the fifth state. Imagine this way. Now when you imagine this way, the source is in one of the n possible states. You can imagine me as the source, and when I leave home until I come to college, how many number of states I can be in. You can visualize. I just told you 5 states till Windsor Manor bridge. Again there's a lengthy road from my home till my college. It is nearly 20 kilometers. And there are so many traffic junctions, there are so many curves, there are so many turning points. You can imagine. Now you can imagine the same way a communication source will have n possible states. For example, a telephone exchange will have n possible states. That n can be 1000, n can be 10,000, n can be 1 lakh, n can be 10 lakhs, n can be 1 crore. It can be any number. It depends on that particular source. So now the source is in one of the n possible states. Imagine that from my home till my college, imagine there may be around 200 states. Okay. It changes state once during each symbol interval, means whenever each symbol is emitted, state is changing. Because after Q it is U, after U it is I, after I it is C, after C it is K. If at all the word quick has to be transmitted, Q-U-I-C-K. Now you can say Q is one state, U is one state, I is one state, C is one state, K is one state. You can go on this way. Which means it changes state once during each symbol interval. Now the probability of this transition is Pij. The probability of me at home, let us say it is Pi. And the probability of me at 11th cross is Pj. Now there is a transition because I am moving. The probability of this transition, that I am moving from home to 11th cross, is Pij, which depends on the initial state I and the final state j, with no dependency on the other states. This is important. No dependency on the other states. What does it mean? No dependence on other states. What does it mean? When I leave home, I am at state 1. When I come to 11th cross, I am at state 2. Now my probability, transition probability of me coming to 11th cross from home is P12. But it has no dependency on the third state, that is Guttalli Vinayaka circle. Because only when I reach 11th cross, then I come to Vinayaka circle. Only when I reach Vinayaka circle, then I come to Guttalli underpass. Only when I reach Guttalli underpass, then I come to Windsor Manor bridge. So, me being at home and me reaching Windsor Manor bridge, even though they are related, the probability wise, they may not be dependent, or they should not be dependent. If they become dependent, our life becomes more complicated. This I had told you earlier also. Let us say from my home till my college, if let us say I pass through 200 such junctions, I can visualize that there are 200 states where I keep on moving. I cannot relate Marathalli bridge with Vinsamana bridge. Even though there is a relationship, I cannot relate because in between there are so many other states. Now things become too much complicated. That is why I told you it is very difficult to model a stochastic process where everything may be related to everything else. In general, in the study of the universe, in the astronomy, sometimes they say that a small event that is occurring on Earth will have an influence on a star. They say that way. A small event that is occurring on Earth, let us say atmospheric pollution that is occurring on Earth, but universe is connected fully. When universe is connected fully, a small event that is occurring on Earth may have its effect on the atmosphere of the moon, or atmosphere on the Venus, or atmosphere on the Jupiter, because through the space they are all connected. So that way it is very difficult to model a stochastic process where there are more and more of dependencies. So what Markov or Markov done is, just to make this simpler, what he did was, he simply assumed the third state will not have a relationship with the first state. So the probability of this transition is Pij, which depends only on the initial state I and the final state j, with no dependency on the other states. The probability of me going from home to 11th cross is dependent only on the probability of me at home and me at 11th cross, that is P12. It has no dependency on the probability of me coming to Guttali circle. Anyhow I am coming to Guttali circle, anyhow I am going to Guttali underpass, anyhow I am going to come to Vinsamana bridge. But let us not relate all of them together, because I will be going to Guttali circle only after I cross 11th cross, right? I will be coming to 11th cross only after I start from home, right? Same way the symbols are transmitted, right? Just like you just visualize that I am that symbol which is being transmitted from home to college. If you visualize that way, this concept will become clear to you. I am going in too much detail on these basics because it is very important to understand this particular statistical model. Only when you understand this statistical model, later on we are going to solve problems for this Markov process. Otherwise, if I straight away go into the solution of the exercises, everything will be hodgepodge. Even though it is simply a calculation of multiplication of probabilities and summation, everything is nothing but multiplication and summation in our course. In information theory and coding, it is simply multiplication then summation, multiplication then summation. But when to multiply and when to add, that depends on the modeling, and there we have to be careful. So we should really understand what we are doing. If we don't understand what we are doing, then there is no point in doing something. That's why I'm going really very slow in discussing this Markov process or Markov process. Now this is the first characteristic of the Markov process or Markov process. Let me move on to the next characteristic. You can see here, let us say from state H to state I, it is PHI. State I to state J, PIJ. From state J to state K, PJK. Now this PJK has no dependency on PIJ, and PIJ has no dependence on PHI. This is my home. Incidentally, it is H only. Okay. This is my home. From home, I come to 11th cross. From 11th cross, I come to Vinayaka circle. From Vinayaka circle, I come to Guttali underpass. Now, from home, when I come to 11th cross, that is PHI. Then from 11th cross, when I come to Vinayaka circle, it is PIJ. From Vinayaka circle, when I come to Guttali underpass, it is PJK. Now imagine there is nothing called PHK or there is nothing called PIK. There is only PJK. If we consider PHK and PIK, then our things become more complicated, and there is no use as such. There is no use in considering PHK and PIK. There is no use in considering from home till Gutali underpass. Why? Because from home I go to 11th cross, then I go to Vinayaka circle, then I go to Gutali underpass. So there is no need to consider the relationship of everything with everything else, which may not be necessary at all. That is called Markov process now, and this is one of the characteristic. To give you one more example, you are all in A section, there are students in B section, there are students in C section, all in 5th semester. Again we have students in the 3rd semester A, 3rd semester B, 3rd semester C. Again we have students in 7th semester A, 7th semester B, 7th semester C. If this is the case, if at all we have to model A section, now this is a stochastic process. In A section, all the students among A section can communicate with each other. Out of all of you, some of you may be close with somebody else. Whoever you are close with, you will communicate more with them. So this classroom itself is completely a stochastic process. In this classroom itself, you will have 6 course teachers now, 6 subject teachers, and along with that you will have lab teachers when the offline classes start. So there is a relationship between these teachers and students also. There is a communication between teachers and students, and there is a communication between student to student. Now if at all we have to model, it is better that we focus only on A section and we model it. At that time, let us not assume that you are communicating with B section students also, or you are communicating with C section students also, or you are communicating with the 3rd sem students also, or you are communicating with the 7th sem students also. If at all we consider all those dependencies, things become still more complicated, but it may not be necessary at all for our purpose. Right? I hope you understood it now, that why a process is called as a stochastic or random, and why is it difficult to model a stochastic process mathematically. So we make our life easy, not we, Markov made the life easy by saying that let us consider only the 2 states relationships, let us not bother at that time about the other states. Okay, now this is the first characteristic. Now the second characteristic is slightly lengthier. It's already time now, let me not discuss it now. The second characteristic of the Markov process, let me discuss in the afternoon's class. Anyhow, in the 5th hour I have the class. At that time, most probably I'll take that class and let us discuss that in the 5th hour. I will be posting the attendance link in the Google class, so please mark your attendance.